Welcome to The Explainer, where we break down big ideas using the source material itself. Today, we're taking this huge, kind of sci-fi vision of the future and smashing it together with a real cutting-edge scientific paper to see if we can actually map out the road to the AI singularity.
All right, let's kick things off with a prediction that's, well, it's pretty mind-bending. It comes from the famous inventor and futurist Ray Kurzweil. And he's not just guessing here. He's put an actual date on the calendar for when everything changes.
Yeah, you heard that right. 2045. And look, Kurzweil isn't talking about, a slightly better smartphone. He's talking about a total, profound, can't-go-back transformation of what it means to be human, all in just a couple of decades. So, what on earth is he talking about?
Okay, so the singularity. It's this theoretical point in time where machine intelligence doesn't just get smart. It gets infinitely more powerful than all human intelligence combined. And I mean everyone. You, me, Einstein, everyone. After that point, technological growth just explodes, moving so fast it would be completely beyond our ability to even follow, let alone predict.
So, what's driving this crazy prediction? It all comes down to this core idea Kurzweil calls the law of accelerating returns. Now, think about it like this. Progress isn't a straight, steady line. It's an exponential curve. It's like a snowball rolling downhill. It starts small, but it picks up speed and mass faster and faster. Each new invention makes the next invention possible even quicker.
And this isn't just a vague idea. He actually laid out a specific roadmap. He predicted that by 2020, for about $1,000, you could buy the computing power of a single human brain, which, we're pretty much there. Next up, he says we'll have a working model of human intelligence by the mid-2020s. Then, AIs that can pass the famous Turing test by 2029. And then, the big one, 2045, the singularity. Okay, I know what you're thinking. This all sounds like it's straight out of a science fiction movie, right? Which brings up a huge question. If this insane, explosive future is just around the corner, how in the world do we get there from here?
Because let's be real for a second. Even our most powerful, most advanced AI today, well, it still struggles. It's amazing for sure, but it's got some pretty major limitations. And a recent research paper really puts a spotlight on this. These popular AI models like DQN and PPO, the ones used for really complex stuff like mastering games or running robots, they can get tripped up pretty easily. They're often clunky and inefficient, their performance can be all over the map, and they really have a hard time thinking on their feet when things get unpredictable. They're just missing that human spark, that intuition.
All right, so let's shift gears. We're going to zoom in from that huge 50,000-foot view of the future right down to the nitty-gritty of a scientific breakthrough that's tackling these exact problems right now.
Okay, get ready for this name. ARDNS-FN Quantum. I know, it's a mouthful, but what's really important here isn't the name, it's the recipe. It combines 3 totally different key ingredients to cook up a smarter, more stable kind of AI. Okay, ingredient number 1, it uses a quantum circuit to make its choices. Now, this diagram looks super complicated, and don't worry, we're not going to do a deep dive into quantum physics today. But here's the one thing you need to know. A regular computer has to check its options one by one by one. This quantum approach, it's like it can look at all the possible moves at the exact same time. That is a total game changer for speed and efficiency. Ingredient number 2 is its memory. It's actually designed to mimic the human brain, so it has a short-term memory for what's happening right now and a long-term memory to store all the stuff it's learned over time. This helps it connect past experiences to present problems in a much more, human-like way. And number 3, and this part is just brilliant, is what they call adaptive curiosity. So if the AI figures out it's stuck, just spinning its wheels and not making any progress, it basically gets bored. It actively decides to get curious and starts exploring totally new and weird strategies to solve the problem. It prevents it from getting stuck in a rut. Okay, so the theory sounds amazing, right? A quantum-powered, curious AI with a human-like memory. But does it actually work? How does it stack up in a real test? Well, when they put it to the test in a really tricky navigation challenge, the results were just, wow. Look at this first bar. The new model ARDNS-FN Quantum had a 99.5% success rate. I mean, that's nearly perfect. It blew past the other powerful established models like PPO and DQN. And it wasn't just about being right, it was about being fast. This chart just says it all.
The new AI got to the goal in an average of just under 47 steps. Now, compare that to the standard DQN model, which took almost 136 steps. That's not a small improvement. It's almost 3 times more efficient.
But as cool as all that is, the thing that really made the researchers sit up and take notice, the absolute biggest breakthrough here was its stability.
Okay, check out this number, 5.424. This is its reward variance. Now, variance is just a fancy way of measuring consistency. A really high number means the AI is erratic. Sometimes it's a genius, sometimes it's a dud. A low number, like this one, is the holy grail. It means the AI is stable, reliable, and performs consistently well every single time it runs. And trust me, 5.4 is incredibly low.
Now, get ready for this. Compare that to the standard DQN model. Its variance, over 252. That means its performance was almost 50 times more unpredictable, more unstable, more all over the place. This, right here, this huge drop in variance is a massive leap forward for building AI we can actually rely on. All right, so let's pull the camera back. Let's zoom out from this one amazing paper and connect it all the way back to that wild 2045 prediction we started with. It really boils down to this. On one side, you've got Kurzweil's vision, which is totally dependent on that law of accelerating returns, that steep exponential curve of progress. And on the other side, you have this research. This isn't just a tiny incremental improvement. This is a fundamental leap, a huge jump in how AI works. This is what that exponential curve actually looks like in the real world.
And as we race down this path, building ever more powerful intelligences, Kurzweil makes a really important point. He says our goal can't just be to make them smarter. We also have to make them wiser. We have to figure out how to embed our most important, our highest human values, right into their core code.
Which leaves us with one last massive question to think about. This research paper, it's just one step on that crazy exponential curve. But as thousands of other breakthroughs like this happen in labs all over the world, we really have to ask ourselves, are we building a future that will one day leave us behind? Or are we building one that will extend our own abilities into a frontier we can't even begin to imagine?